In this sector, we are going to talk about economies of scope and cost complementarity. Okay, so this is the case where multiple products, the production of multiple products are involved. So here, Q1 stands for the quantity produced for product 1, and Q2 stands for quantity produced for product 2. Assuming all inputs are used efficiently. Okay, so here let's look at the definitions first. Economies of scope. It is defined as when the total cost of producing Q1, that is product 1, and Q2, that's product 2 together, is less than the total cost of producing Q1 and Q2 separately. Okay, so here in this math expression, it is saying that the cost of only producing Q1 plus the cost of only producing Q2 is greater than the cost of producing Q1 and Q2 altogether. Why is that? Well, here is a good example underneath, which is restaurant. Say, steak dinners and chicken dinners, those are two different types of products. Steak dinner being Q1, being type 1, and chicken dinner being type 2. And conceptually, we know generally it's cheaper to produce both products in the same restaurant than to have two separate restaurants. One sells only chicken and one sells only steak. The reason is that, well, producing the dinner separately would require duplication of many common factors of production, including ovens, refrigerators, tables, a building, and even, I would say, waiters, right? So because of producing these two products, they can share the utilization of many, fundamental production facilities. Then it is less rational to have these two products to be produced separately, right? So if a joint production will yield less total products than separate production of these two products individually, then there is economies of scope. Okay. So here, that is to say, a bigger scope make it more economy, namely cost reduction to this firm. Okay, and then cost complementarity, that is to say, well, in a multi-product cost function, when the marginal cost of producing one output is reduced when the output of another product is increased. Okay, again, it is echoing to the example that we see above. All right, that is to say, if we start to produce more type 2, say chicken, right? Then the marginal cost of producing steak will be dragged down. That's what we see. Namely, increasing in the output of product 2 decreases the marginal cost of producing product 1. Why is that? Because some of those facilities in common can be shared, so the cost averaged on each additional unit of produced will be smaller. Okay, here there is an example underneath. The production of donuts and donut holes. The firm can make these products separately or jointly, but the cost of making additional donut holes is lower when the workers roll out the dough, punch the holes, and fry both the donuts and holes instead of making the holes separately. Okay, so here in a cost function, the constant term here is noted as F. All right, the coefficient, namely the multiplier ahead of this cross term, Q1 multiplied by Q2, is noted as A. And for a quadratic form, we have this conclusion. You can directly jump to this conclusion. I don't require you to derive all of them. If you're interested, and if you're a math person, you are encouraged to go over those steps, but I don't require memorization of all those steps. Okay, so basically the conclusion is that if A, which is the coefficient of the cross term, is smaller than 0, then there is complementarity. Okay, and if f minus a q1 q2 is greater than 0, then there is economies of scope. And here it is by just plugging in those expressions into the original definition, which is producing each of these two products alone, and their total cost combined is greater than the total cost of producing two products taken care of by one firm simultaneously. Okay, that is to say the left-hand side is greater than the right-hand side. You plug all those expressions in, you will get this result. All right, so now let's look at the application of this. Okay, so I just copy down those conclusions. And here we are looking at the number, at the example, which is taken from your problem set 3.1. Okay, so if A is smaller than 0, there is cost of complementarity. If F is greater than A Q1, Q2, there is economies of scale. And here, let me note clearly what are those A and F. Okay, so C Q1, Q2 equals to F plus A Q1, Q2 plus Q1 squared plus Q2 squared. All right, and then in this case, where we have a more explicit numeric version of the cost function, which is 90 minus 0.5 Q1 Q2 plus 0.4 Q1 squared plus 0.3 Q2 squared. Okay, the complementarity is found. Now let's go to the easier one. The complementarity is found by looking at A, and A in this case, which is the coefficient ahead of the cross term. So A is minus 0.5. Okay, and then the conclusion should be that A is, so here A is smaller than 0. The conclusion should be that, yes, there is cost complementarity. Okay, then let's look at economies of scale. So to look for economies of scale, we need to find F. In this case, F is the constant term, which is 90, right? And A is minus 0.5. Don't forget the minus sign, because here it is, in this original expression, it is plus A. Then here, the entire minus 0.5, that is the A. Okay, so in this case, the question also tells you Q1 equals to 10 and Q2 also equals to 10. All right, the original expression condition in the textbook, given by the textbook, is F minus A Q1 Q2 greater than 0. What I did was to move A Q1 Q2 to the right hand side, right? Minus A Q1 Q2 to the right hand side and change the sign, so it is actually F greater than A Q1 Q2. If the answer is yes, then there is economies of scope. Okay, so F is 90, which is left hand side. A Q1 Q2, actually you don't have to calculate. It is a minus 0.5 by two positive numbers, which is smaller than 0. But the left hand side is greater than 0, therefore F is greater than A Q1 Q2, which is a negative number in this case. The answer is yes, there is economy of scope. Okay, I hope this explains. Thank you.